Yes, there were a lot of questions on the labs. So the labs is really for practice for you guys. You know, most of these labs are to be done with physical items at your disposal. But given the circumstances, we don't have those resources. So the labs are for you to basically improvise and try and gain as much understanding. For those persons who have sent me results via email and posted them, very good. All right, I've not finished marking everybody as yet, but I'll finish and post their grades by tomorrow evening. All right?
So even though I not complete mine yet, still I must still upload when I
Send it.
complete.
Yep. You see, it's a matter of for me, it's a matter of understanding. All right, I want to see if I don't give any feedback, I am comfortable with where you're at in understanding, and I hope that you're not copying and just pasting stuff. And I hope you understand what you're doing, and I'm also hoping that you ask questions in class, so you
Oh,
know you gain your level of understanding.
okay,
All
sir.
right.
So if you complete 2 pages out of the 4 what you send, just send the two what we get from sir.
Yep.
Alright.
So we look at that, and I hope you guys have completed chapter 3 and chapter 4. And I know you guys are you were all successful, and I have not looked on the grade as yet, but I'm confident that you guys would have done great. All right, I'm very confident, so I look on the grades this week. Also, as it relates to the checkpoint exam, the checkpoint exam will be for this weekend. All right, we're gonna do chapter 5 and checkpoint exam this weekend. All right, we're gonna finish chapter 5 today and start chapter 6 for next class. All right, chapter 5 is a lengthy chapter. I have to go through it slowly, just as I did chapter 3, because it is what the springboard for the other chapters coming along. All right, so we are gonna take our time and we will go through it. And I'm hoping that we ask questions as we move along. All right. So for last class, we look at we look at connectivity, network topologies, um, basic abbreviations like LAN, PAN, VLAN. We look at the network icon that we will always see moving into um, the course, and not only the course, but on our day-to-day. All right. So we talk about the metropolitan, we talk about wide area network, talk about VPN, which is virtual private network. All right. I did some explanation on it. We talk about ISDN, and ISDN and analog telephone. Those are legacy technology. All right. They are not used anymore, and unless that region is so far behind in technology, they are using it. Okay. And then we talk about broadband, different frequencies and such. We talk about DSL, ADSL, talk about cable, talk about fiber. All right. We give example. All right. And we talk about wireless internet service. Talk about hotspot, if I remember well, and tethering. We spoke about also satellite connectivity. All right. Cellular communication. And I hope you guys were reading over and do your own revision and research. All right. We talk about cellular. We spoke that it relies on the towers, and we are now at networking protocols and standards and services. So we're at networking protocols, standards, and services. All right. as I mentioned before, that this portion of the course is exciting. All right. This is where the excitement begins, and we will see and enjoy it. All right. So we talk about protocols, transport layer protocols. All right. We are going to go, what I'm going to do first, I'm going to introduce the topic via video. All right. And from this video, we'll move forward. Give me a quick minute. I'll get it up. Get this video right here in a second. Okay, chapter 5 video. Where is it? All right. I hope I label this video correctly. Okay, let's start. I'm gonna share my screen right here. Optimize and audio. I'm gonna share, and we're gonna start now. All right. Wait, you guys can see my screen?
Yes.
Okay. Make sure volume is up. All right.
Move
Play.
to 5.2 Network Protocols, Standards, and Services. TCP/IP model is a standard protocol used for data transmission over a TCP, which is the transmission control protocol, is under the transport layer of the model and is responsible for ensuring that the data could reach the destination reliably and in order. IP is the Internet Protocol, which is responsible to the addressing in order that the data could be routed to the intended destination. If we try to look intently on the transport layer, you will see two types of protocols, the TCP and UDP. Let's discuss them one by one. As I mentioned earlier, TCP is responsible for ensuring the reliability of data transfer from source to destination. It means that it makes sure that all of the data arrives at the destination. There are three operations that are happening in this protocol. Number one is the numbering and tracking of data segments to a specific device from a specific application. Let's observe what is going on in the given network. As the file is about to be sent using the FTP, the TCP records that communication and then segments the data into 6 parts. The information about the number of segments will be the basis for a successful receipt of the entire data. By the way, we segment the data so that it will be easier and faster to move them from source to destination. When the data is received by the destination, it will send an acknowledgement that data has been received, and that is our number 2, acknowledging the received data. This validates that the data has reached its target destination. Suppose the remaining 3 segments did not reach the destination. Definitely, the destination will not acknowledge anything. This will prompt the sender to resend the remaining segment, and that is our number 3 operation, which is retransmitting any acknowledged data after a certain period of time. Since TCP keep tracks of the data segment, it could identify for any unsuccessful data transfer. With that, the remaining data segment will be resent to the destination, and the destination will again acknowledge the received data and forward that packet to the source, alerting the source for a successful receipt of the data. On the other hand, UDP or User Datagram Protocol works differently. It does not provide any form of reliability, meaning to say, it does not care whether the data has successfully reached the destination or not. Let us observe what happens in the given network. When a file is about to be sent over the network, UDP segments the data and then sends all of it to the destination. UDP uses the best effort delivery protocol. This is considered unreliable because there is no acknowledgement that the data is received at the destination, as you see in the animation. Moving on, what are port numbers? According to one definition, port numbers is a protocol used to uniquely identify a specific process to which an internet or other network message is to be forwarded when it arrives at a server or destination. It gives a unique identity that separates it from the other process or protocol. There are 3 types of port numbers. These are well-known ports, registered ports, and the dynamic or private ports. The range of well-known ports is from 0 to 1023. Registered ports are ports that are assigned by the Internet Assigned Numbers Authority or IANA or by Internet Corporation for Assigned Names and Numbers or ICANN. Meaning to say, it is for use with a certain protocol or application and it must be applied and registered. The range for registered ports is from 1024 to 49151. Dynamic or private ports are not assigned, controlled, or registered, meaning anyone can use these ports that ranges from 49152 to 65535. To have more details about port numbers, I encourage you to take the CCNA Introduction to Networking version 7 training. There are a number of different types of application layer protocols that are identified by TCP or UDP port numbers at the transport layer. We do have the World Wide Web related protocols, email and identity management protocols, and the file transport and management protocols. We also have the remote access protocols and the network operations protocols. The next slide shows summary table of all
Okay, so all right, we're gonna go through more of that video and other videos as we move through the class. All right. So we're talking about network protocols. All right. And there are a couple of protocols that we talk about. All right. And one of the protocols that we're going to be talking about today is the transport layer protocols. Those protocols we're going to talk about. All right. So the transport layer protocols, all right? We talk about TCP IP model, all right? And this model, as the kind gentleman in the video was explaining, that it's TCP is how we transport information across the network from one point to the next, all right? And this model comprises of 4 layers, all right? And the 4 layers are application layer, the transport layer, internet layer, and the network access layer, all right? And within the application layer, which is the first layer, as a matter of fact, to remember that the 4 protocols, you can just use the acronym ATIN, which is ATIN, Application, Transport, Internet, and Network Access. All right, so on the transport layer, you talk about applications such as file transfer protocol. You talk about HTTP, which is the www dot protocol, which is Hypertext Transfer Protocol. You have the SMTP, and that's SMTP. It's basically the email protocol. SMTP stands for Simple Mail Transfer Protocol. Then we have DNS, Domain Name Service. What it does is to resolve a number to a name, or a number to a text, or a text to a number. Then we talk about the TFTP, all right? We're talking about Trivial File Transfer Protocol, all right? And these are used to transfer files across network, all right? So it's the same thing as the FTP. Then you have the transfer layer. The transfer layer, it has the TCP protocol, and it also has the TCP, and it also has UDP. All right, and the kind gentleman in the video went on to explain that TCP is what you call reliable transfer of information. All right, because what it does when it transfers particular information, it also waits for a response, and the communication is not complete until the sender, the receiver respond that yes, I have gotten the message, or yes, I've gotten the message, but only some piece of it, or yes, I've not received the message at all. Then you have UDP, all right, which is the best effort. It's one of those people who deliver the message, you know, like a postman, and they put it in a mailbox. They don't care if you see it or not, and they are not looking back for any response either. So they just put it in a mailbox, leave it, and gone about them business, because they do their job. You find it and you deal with it, but you don't need to tell the postman anything. All right. On the internet layer, you have IP, which is that protocol. It's IP stands for Internet Protocol, and what it is that major protocol that works on the web, the internet. All right. And we have a network access. We talk about the LAN connections or the WAN connections. And that is how you get connection to the network via your local area network or wide area network. All right. And those connections are what the information comes to you and display. Okay. So we talk about TCP protocol. All right, and I mentioned to you that it is a reliable protocol, reliable transfer protocol. All right, so whatever application that you are using, or whatever application that needs reliability, they will have to rely on the TCP. All right, rely on TCP protocol. All right, so talking about SMTP, that is reliable, because when you send an email to somebody, you can't just send it and it goes into oblivion. You don't know if the person get it or not. And we're not talking about the next person as in responding, talking about all the email servers communicates with each other. So when I send an email from my desk, it goes through my email server, and my email server communicates to this receiver email server, and that email server will respond to say, I get the message, this person resides on my mail server, so I get it and I'm going to send it to that person. Now, if that email address is not residing on that email server, then that email server will respond and send back a message to say, listen, I don't know who you're talking about. That person is not here. All right. And so your server will respond and tell you, listen, undeliverable. All right. This mail is undeliverable. Can't find particular user. We don't know that user. All right. So that's why it is reliable. All right. It acknowledges data. It resends lost data, and it delivers data in sequence and in order as a matter. So those features of TCP, those 4 features that are there, they are features of TCP. So it's reliable, which is most important. It acknowledges data, so it will let you know that I received this here. You understand? And if there's because the data is numbered or in sequence, is numbered in segments or pieces, let me say in pieces, and each piece is of a different number, and also the receiving party will know how much pieces of this or segments or pieces of data to expect. You know, like when you send when somebody send a package to you, all right, from overseas via DHL or UPS, and they will put on the slip, sent 4 packages, all right, but yet still when everything come, you only get 2 packages, and you are wondering what is happening. So this is what happens. It resends lost data, you know, so TCP will ensure and keep trying again and say, hey, listen, I didn't get all of it. Based on what you said you were sending, and I'm going to send back to you and say, listen, I didn't get all of it. And TCP, how it will work is say, boy, all right, let me look for the rest and send it. Or let me look at what was sent in the beginning, and then I'm going to send everything again, and what it will do is pick out what I want down yonder at the bottom there. All right. Class, I'm trying to give it to you in a everyday scenario for you to understand, and I hope you're understanding. So let me know if you are understanding. If you're not understanding, let me know also by raising your hand or doing something.
Sir, I don't understand, The one
Okay.
that you're explaining just now, it's for TCP.
TCP. I'm talking about TCP right now.
Okay.
So TCP is a reliable protocol. So we're talking about network protocols, right? Talking about network protocols, and network protocols, the way communication take place across a network, it via the protocols, it using a model, and that model is a TCP IP model. As a matter of fact, it's more than one models. You have the TCP IP models, that's one which is very popular, and then you have the OSI model also. OSI model has 7 layers. All right, TCP/IP has 4 layers. It basically works the same as the OSI model, is that some portions of it are integrated into our, we'll say, concatenate, and it makes it smaller. So take, for instance, the network access will have 2 of the OSI protocols integrated to give you only 1. You understand? And the application will have 2 of the OSI model layer integrated into each other, combine and give you only 1. So that's why you end up with 4. You understand? But these models are different. But the popular one that is used now is the is the TCP IP model that's used. All right. So that is what dictates how information is transferred across network, across any network. All right, the TCP/IP model. So keep that in mind. That is the base for you to know. There's a model that tells how data is transferred from one point to the next over the network. And that model is the TCP/IP model. On these model, you have different layers, and different layers consist of different we call it technology then. And then you have the protocols on the layer. We have the TCP/IP protocol. You understand? Which consists of, you have the transport layer, which consists of TCP and UDP. And it also has the internet layer, which is IP. So the LAN connections, those are talking of the cable and the network interface card that is in your computer, and the cable that is connected to the network interface card. All right, an application, we're talking about how the data is transferred across the application that you use to transfer data across the network. So you have file transfer protocol, and that file transfer protocol, you're talking, say you are downloading something from the internet, or you're uploading from the internet, you are using the file transfer protocol. All right, or you are copying something from the server to your workstation on your network at work, at your place of work. Right, so that is file transfer protocol. You have the hypertext transfer protocol now. That is the protocol that is used on the World Wide Web. All right, that's the popular protocol. All right, then you have the HTTPS, which is the secure version. So with the S on it, it just means that it is secure. All right, and we talk about the email protocol, which is an application also, which is the simple mail transfer protocol, or you can say message transfer protocol if you want to. All right, then you have DNS. How the DNS work, and I'm going to give it to you like on a network or on the internet. So I'm going to give you an example how the DNS work. So when you type in www.google.com in your web browser, right? What happens is that that Google server, or there are multiple Google servers, right? But the closest one that will pick up that request is as a DNS server with an IP address. Take for instance, it's 65 that, let me say it's 65, no, like 0 that, let me give you a number that is legit, like 65.256, no, 245.133.110. That is the IP address for that computer that you want to get to, the Google computer that you want to get to. All right, but when you type in google.com, right, it is translated and resolved to that numeric value, which is the IP address of that computer, because we as users will not be able to remember all the IP addresses for all the servers on the internet. All right, so the best way to have it for every one of us is to ensure that it is resolved to familiar, recognizable names. All right, and I will explain to you, giving an example short from now. All right, and then we talk about the TFTP, which is also another file transfer protocol that is used across the network. All right, I'm basically going back over what I said earlier. So we talk about now the transport layer is what we are on now. This is the focus, right? The transport layer consists of the TCP protocol and the UDP protocol. All right. Now I'm going to talk about the TCP protocol now to tell you that it is of the two protocol, TCP protocol is a reliable protocol. These are the features of the TCP protocol. It's reliable. And reliable meaning that the information that it gives you, you can say it is fact, it is real, it has integrity, it is trustworthy. All right? The data that comes, and the reason for it acknowledges data. All right? And it resends lost data. All right, it delivers data in sequence order. Now, those are the features. And one I think is that when TCP transferring information, it's segmented in sequence and given numbers. So that means that if you have 10 pieces of data coming, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, and they are labeled by the numbers, right? Each sequence number. If you receive 9 and 10, 4 and 5, and you don't receive 6 and 7, 8, and 3, 4, I'm sorry, and 3, 2, 1, if you don't get those, then TCP, based on how the protocol work, the receiving party will know, and then respond to say, listen, I have not received all the package, all the information in the package. So you have to resend it. And TCP IP will send back that data, the last data again. So you will end up at the end of the day or the end of the transfer, you will either get the full information correctly on screen, or it will comes up and tell you that, hey, we can't get the information for whatever reason. So it is reliable. It's not going to transfer information to you that is of no use. So it's either transfer it or it don't transfer it. But you will get a message to say, hey, we have locked the packet. All right. Now, as it relates to UDP, UDP is what we call best effort. All right. And the features of this protocol is that it is faster than TCP IP, because guess what? It's not doing any checking. It's not checking for any errors nor nothing. It just can't drop it off like the postman. Postman get the letter from the post office, whether you're there or not, and if you're in business, and put it down in the post box and gone. Somebody want to rob your post box and take out your letter, and if you're in business, because he knows saying drop it off. You understand? If somebody want to open it and read it, the postman don't care. And drop it off in your post box and gone. No, that's how the UDP work. And guess what? It has low overhead, meaning it take less resources on the computing or the computing networking portion of the transfer. All right, because it's not trying to say, let me use more memory or whatever to say, to check, to make sure that everything is okay with this packet and that the user get every single pieces of the data that I send. All right. And it's not going to say, let me label it and let me wait for a response and let me try and resend it again. Resend it. You understand? UDP does none of that. UDP just bring it, put it down, and go about in business. Your business, you have to sign it. All right. It does not require acknowledgement. Postman don't care if you want to send me receive it or not. And it does not resend lost data. Only one letter the postman gets here today. And if you lost it or if somebody lost it, somebody take it out and cannot get it back to give it to you. So now no resending at that data. All right. And it delivers data as it arrives. All right. So it's not checking to ensure that the data comes in and comes in correctly before it delivers it. As it come, it deliver it. In a business, which number I come in at? Or if you come in at the number back and front, and I try to build it back to say it came in 10, 7, it's not going to put it in order to ensure that you have data that makes sense. You understand? So that's what I'm trying to explain, the difference between TCP and UDP. One is more different from the next, but they both have their usage in the networking, in communication. All right? Any questions, class?
Which one of them you would not classify better? The TCP, right?
TCP is reliable. It is, that protocol is utilized in when they are for this specific need. And when I say specific need, I'm talking about softwares, applications, you know. So for instance, if you need something, if you need reliability, if the data that you are sending is critical and important, whatever protocol that is going to use to transfer that data, it will have to be TCP. So they both have their usage. It depends. So if you look on the screen, and my screen is showing you that for for browsing the internet, you need TCP, because you can't just type in Google what is X, and it brings up all kind of foolishness or you know what to look for. It need to respond to you and to tell you what it find, right? That's why TCP is used on those applications. And you're talking about your email. You want to, when you send an email, you want to know if it reached or not, or if it was bounced or something. And that's why you have to use a reliable um, protocol, which is TCP. All right. And if you're talking now like on a telephone, right? If you notice, it is faster, right? UDP is faster. So you want to think that, okay, why would we use TCP on a telephone conversation? Why would we use TCP on a telephone? Just a moment. Right, I'm sorry about that, class. So I'm saying, if you um engineers knows that, listen, if I'm going to make a telephone call, right? When I take up my phone, dial a number and say, when I dial a number and I send over a message and say, hello, good afternoon. I am hoping that the person hear me to answer me, but I am not going to check to see if my data get to you or not. I'm talking the technology side of it. You understand? And if I don't hear any answer, because that message that I just typed gone in oblivion, I will just say it again. Hello, how are you? Until somebody answer me on the other side of the phone. So UDP is not checking my voice packets to see if it reach, to tell me say yeah, it reach safely. No, it don't make no sense. You want information to go faster. The time it will take to check, by that time you probably the time it make communication over the telephone slow. All right. So once I utter out my mouth and the packet reach, you will hear what I'm saying. If you don't hear what I'm saying, you're gonna answer and say to me, say, you don't hear me. Understand? So I'm talking now, class, about the individuals different from the technology. So the technology not checking it. But if you hear me, you will answer and I will know you hear me. But the technology not checking it. All right. Now, as it relates to video, live streaming video, it it takes too much overhead. It takes too much bandwidth. It takes too much time to, when you're streaming video, to be checking if the video coming across good or not. No, you're not checking anything. We're just sending through the video. All right. I was hoping that you're getting it. And if you're getting it, good for you. That's what we want. But if you're not getting it, boy, you just have to just work on something, your bandwidth or so forth. You understand? So when you're streaming live video, it's UDP protocol that is utilized in those applications. UDP protocol, because you want to use less resources. You want it to be fast. You understand? So when live video is streaming, comes across fast because they're not doing a whole heap of checking and balancing and those stuff. You understand me? So that's why when you go to a supermarket, the lines move faster at a supermarket than the line at the bank, because people checking and balancing, they don't want to make any issue errors. Supermarket people just cash in. All right. So basically, that's how you look at it. All right. If you understand my simple basic analogy that I'm trying to put to you, let me know so that I can move on. If not, I'll try to do it again.
No, understand so far.
Okay. All right. What I can do also, I can bring up a different video. I'm going to continue that video, but I'm going to bring up a different video now to bring forth some more information. All right. Just give me a quick moment.
This lecture today, we are going to begin our discussion on the transport layer. So we finished application layer in the previous.
All right. Hold a moment.
Hey, what's up guys? Welcome to CertBros. In this video, we're going to be looking at port numbers.
Not you. Where is it? Transfer layer. Okay, there we go.
This lecture today, we have
Share. You optimize. All right, so we're going to talk about transport layer. All right, like I said, in this chapter, we take our time. Want to make sure your understanding, we get your understanding built up properly. All right. Can you see my screen?
Sure.
All right.
Hi everyone. In this lecture today, we are going to begin our discussion on the transport layer. So we finished application layer in the previous lecture, and we are going to move on to the transport layer. So what are the goals about our discussion on the transport layer? We're going to just get started with this video, and then the following video we will also have further discussions about the transport layer. So our goal here is to understand the principles behind the transport layer services. So different transport layer services that are there are multiplexing and demultiplexing. We'll talk about reliable data transfer and a little bit about flow control and congestion control. So the internet protocols which use these or provide these services, we will study a bunch of them that are UDP and TCP. So UDP is an example of a connectionless transport protocol, while TCP is an example of a connection-oriented and reliable transport protocol. We'll also talk about TCP's congestion control. So a lot of the discussion in the transport layer is going to be focused on TCP, and that's a very interesting topic, and we'll get to that later. So this is outlined, and we're going to, in this lecture, we're just going to talk about the transport layer services. So what does the transport layer do? The transport layer provides a logical connection between the end host. The most important thing to note is that the end host runs all the layers of the protocol stack, starting from the application right all the way to the physical, and the transport layer provides a logical connection between two application processes running on the different hosts. So that's a logical connection between two application processes. So what the end hosts are going to do, they're going to break the application layer messages into segments, and this is the word that or the terminology that we're going to use for the transport layer. They're going to break each of those application layer messages into segments, and these segments are going to be passed through the network layer. The network layer is going to take care and of transporting these segments all the way from one host to the other, and at the receiver side, these segments are going to be reassembled into messages that have been passed to the application layer. So once again, I want to iterate that the goal of the transport layer is to provide a logical connection. It's not a physical connection, it's a logical connection between two application processes, that run between hosts. So it's a single host can run multiple application processes, and the goal is to provide a logical connection between application processes. Okay, so one of the major differences between the transport and the network layer, the transport layer provides a logical connection between processes, and we'll understand this in greater detail as we move on with our discussion about the transport layer. The network layer, on the other hand, provides a logical connection between end hosts. So there's a subtle difference. In a host, there can be multiple processes that run, and the transport layer provides logical connection between those processes, while the network layer just provides logical connection between the hosts. So let's look at a household analogy which will help us understand this concept better. So let's assume that there are 12 kids in Anne's house, and there are 12 kids in Bill's house, and Anne and Bill are responsible for carrying letters that these kids write to each other. Okay, so this is the setup. So there are these kids who love writing letters, and they write letters to each other. So here the hosts are, if you want to make a comparison, the hosts are the houses, and the processes are the kids. So in a house, there are multiple kids. In fact, there are 12 kids in each of these houses. So there are multiple processes between each host. Now, each of these application layer messages is a letter. So each of these kids can write multiple letters. So each of those letters is an application layer message. Now, the transport protocol that's acting here is RAN and Bill, who are responsible for collecting these letters from the kids and, and then handing it over to the postal service. And on the other hand, they're also responsible for getting the received letters and then distributing it among those kids. So that is the goal of the transport protocol. They are doing this demultiplexing and multiplexing job of forming this logical connection between the different processes. Those are the kids here. So the kids just hand over the letter to RAN and Bill, the transport layer protocol, and it's their responsibility to make sure that the kids, the letters reach the other kids. What RAN and Bill do is they just hand over the letter to the postal service. The postal service is equivalent to the network layer protocol. What it does is it establishes this logical connection between the two hosts, in this case the houses. So the postal service is responsible for delivering all letters between the two houses. I hope this helps you understand the difference between the transport and the network layer. So how does the internet transport layer protocols work? There are two protocols. One, as I said, that they're going to form this logical end-to-end connection, and there are two protocols that we will study. One is TCP, that helps in congestion control, flow control, and is a reliable data transfer protocol. The other one is UDP, which is unreliable as well as unordered. The reason with why we study both these protocols is UDP is unreliable and TCP is reliable, so we can understand the amount of complexity that is needed to go from an unreliable protocol, which we'll see is pretty simple, to a reliable and in-order delivery protocol such as TCP. So I would like to make sure that what are the guarantees that the transport layer does not provide? The transport layer does not provide any guarantees of delay or bandwidth. Remember that the internet is a best effort service. So it has never been designed to provide any strict guarantees. It does not provide any delay guarantees, neither does it provide any bandwidth guarantees. So neither TCP nor UDP provide any of these guarantees. With this, we will end this lecture, and in the next lecture, we will begin by discussing about multiplexing and demultiplexing in the transport layer. Thank you.
Okay, class. I hope that guy wasn't too complex, but I tried to give you a basic run of it. I just wanted to hear it on a different view. I don't know if you guys get anything from that video, but I hope you did. Did you get anything from that video, class?
Well, a bit still.
A bit. All right, cool. So, all right, so we're gonna move on into on our slides. We're gonna move on onto our slides. All right, so as we're on the TCP/IP model, we are the transport layer protocol. All right, so TCP, oh, I don't think you're seeing my screen. Are you seeing my screen?
No.
Okay. All right, here you go. You can see now?
Yeah,
All right, so as I explained earlier, for TCP, the three basic operations of reliability is that how it works, how it gets to be reliable, is the numbering and tracking of the data segments. All right, so each data segment has a number and it tracks it as it transfers the data or the packets across the network, so that when it reads to the next point, from one point to the next, it can say, boy, it was 5 pieces that were sent and I only received 2, or I've received all 5 pieces, and acknowledge and say, acknowledge, we have received everything. All right. Then you have acknowledgement of data, the data that is received. All right. And then it retransmit any unacknowledged data after a period of time. All right, so it will try over a period of time to resend, and if it's still not getting through, it will then just say connection timeout, or it will say unable to complete task, or something it will say to let you know that the information was not sent completely, or it was not sent at all. All right, so that's why we consider TCP/IP reliable, because of these functions that are embedded within this protocol. All right, as it relates to UDP, I'm going to go onto our NetAcad and I'm going to show you some videos also. As it relates to UDP, and I mentioned before, it has very little overhead and it does not do any data checking. It doesn't check for nothing. All right, it's a best effort. It makes it just do what it can do the best way it can. All right, which is it just deliver and it don't care. It don't want any acknowledgement. It doesn't business. All right, and that's why it is no acknowledgement that the data is received by the destination. All right, I'll give you an example regarding the postman. All right. All right, so we're at port numbers. All right, so let us look at, just a moment. I'm gonna look at port numbers. All right, class, any questions? Any question while I'm moving through the slides and so forth? Any questions? Nope.
Not right now.
Okay. All right. So let me get here. .1. All right, I don't want to move from transport layer protocols until I do your check understanding. I want to ensure you get it. I have to make sure your base is good. All right. So I'm going to share my screen. Audio, optimize, share. All right, you can see my screen, right?
Okay.
All right, let's do this video.
Network communications involves a suite of protocols known as the Internet Protocol Suite, or more commonly known as the TCP/IP Protocol Suite. This protocol suite includes all the protocols used in various aspects of end-to-end network communications, including addressing, routing, and reliability. The TCP/IP protocol suite is also a conceptual model that classifies and organizes the various protocols into 4 different layers: network access, internet, transport, and application. The transport layer includes 2 protocols: TCP, Transmission Control Protocol, and UDP, User Datagram Protocol. These protocols determine how the data will be delivered, reliably or unreliably. It is up to the network application to choose. If the application chooses TCP, the data will be delivered reliably, with guaranteed delivery and assembled in the proper order. Or it can choose UDP, when the data needs to be delivered as quickly as possible, with some tolerance for loss of data. TCP adds some overhead, which means there will be some additional delay. For example, the network application HTTP uses TCP to make sure all the data is delivered reliably. Here, the user types in the URL www.mybank.example. TCP is used to transport the information reliably between the user's computer and the web server. The web server also uses TCP since the requested data, the web page, separate segment. Segment is assembled in the proper order. UDP is used to send data. Network applications such as sending voice and in order for the data to be delivered data as quickly as possible. As you can see, UDP does not include any functions for reliability, such as there are no sequence numbers in the UDP segment. Such as downloading web pages and email all use the Reliable Transport Protocol TCP, whereas UDP is used for applications such as real-time video and voice. Speed is more important than quality.
Okay, class. All right. Any questions regarding that video? Any questions, class? Are you guys there?
No, sir.
Okay.
Sir,
Yes, sir.
all these videos can be found on the NetAcad website, right?
Yes, sir. In fact, I'm on the
Okay.
NetAcad website right now.
Okay. Normally, my learning method, I have to repeat, and drill them into my head. So that's good to know.
Fine, that's okay. That's as a matter of fact, that's why I request that everybody ask questions. So you can say it. You can, when you ask a question, you get a different answer. You will kind of deepen your understanding. And I say you need to review. You always review what you have done and read ahead. All right. So we are at check your understanding. We are check your understanding and just to ensure that you guys you have understand what you have just gone through. All right, I spent a little time on it. I wanted to capture this base. All right, so choose whether the statement is true or false. All right, and these are the statements. The transport layer has only one protocol, like the internet layer. True or false?
False.
False. Okay. And it tells you the transport layer has two protocols, TCP for communication that require reliable transport, and UDP for communication that can tolerate some data loss. All right, so remember now, these are protocols. These are protocols that are used within the data transfer across networks. So when you're thinking networks, that's what you're talking about. All right. All right, next question. Some application layer protocols use only UDP. Is that true or false?
True or false? I'm not sure.
Everybody agrees on true or false?
Yeah, that's a true.
Sure, that you will.
Okay.
That's a
Yes.
true.
Yeah, it is true. It's fact. Some application layer protocol use only UDP and some only use TCP. All right. And some use both.
That's true.
Some application layer protocols can use both TCP and UDP. True or false?
True.
True.
Some application layer protocols use neither TCP nor UDP. True or false?
False. False.
Correct. Right? At minimum, they must use something. All right. So let's move on. At least I'm confident. I feel better that you guys understand that so far. So we have gone through here. All right. So delving some more into the transport layer protocol. All right. I'm just going to play this little animation here so that you can have an idea what we're going to talk about segments and so forth and so forth. All right. And this one is regarding TCP. All right. So if you look on it, the first thing happen, you have to remember now, when we are discussing TCP and we're talking about networking, everything that we're talking about now is networking. It's not just on a standalone computer, please. Talking about networking. All right. So the first thing happen, all right, a file is sent to a server using the file transfer protocol. Remember I said moving file to and from location on a network uses the FTP, the file transfer protocol, right? So it's a file is sent using FTP application. TCP tracks the conversation and segments the data to be sent into 6 segments. So one file is going to be sent in 6 different pieces. All right, so look at the movement. So, see it? All right. So you notice information is sent. Information is sent across the internet. See the routers here. This is your from your house. You're connected to either Flow or whoever your internet provider is. It goes over to the internet, the World Wide Web, and it comes down to wherever these people, them persons here, them probably in Germany or somewhere. All right, or Canada or US, wherever you send that email. The file server acknowledges the first 3 segments received. So everything was sent. Watch again, start again from the beginning. That is the email or the file, whatever it is, say a file, a Word document. All right. 6 segments are going into now, 6 segments, remember. So the first 3 segments, there they are. Go to the FTP server. This server respond back to this user, the user, and then the second set is sent. Now, you need to understand, the user sent this file, but the user does not know what is happening in the back end, remember. So even though it comes back and it's like, oh, it comes to the user and the user click a button again. No. The user only send the file one time and the user don't business with nothing else again. But the application, the TCP IP model, that is going to take that information, that piece of data, and transfer it across the model to the user. So the first thing, it uses the application layer, which is the FTP, and then it into the bring it into the transfer layer, move it to the transfer layer, which comes right after the application layer, right? And then to the internet, right? And network. All right, so if you look at it now, the user do what he's doing, just one thing him do, and he just send the file using FTP, the application. All right, and the application does everything else for him. So he does not know what is happening, but it is happening. So right here, no segments, no, let me bring it back here, I'm sorry. Let me take my time. I want to take my time. So the user send a file. It is then segmented into 6 segments. All right, using FTP, and it's going to go all the way across the internet. 1, 2, 3 segment first. All right, and it goes to the FTP server side. And that is if and the file server acknowledge that it received the first 3 segments by sending the acknowledgement. See acknowledgement coming around to this server. All right, and then it's gonna send the additional 3. See, it goes there all the way around to the internet. And all right, so but guess what? It did not come here. It lost in somewhere in space. All right, and so no segments are received, no acknowledgement is sent. All right, so look at it. The next 3, see them? There they are, and they get lost in space. All right, and no segments received, and it was expecting 6, no acknowledgement sent. All right, the client then resend. When I say the client, I'm not talking about the user, because the user does not know what is happening. You resend the final 3 segments. I resend, so it's doing it over, and there they are moving, and they come down, and they come down, and they get to the destination. They get there, so the final 3 segments are received and acknowledged, and an acknowledgement will now be sent back around to say, yes, I have received it. See, acknowledgement going around. Here it is. Here it is, and it comes back around. That's how TCP works. All right. That's how TCP works. The data is split up in segment, and it's transferred, and each segment is numbered and it's tracked. All right. And so when it gets to the destination know that some is missing. No acknowledgement is going to be sent, and it's going to resend again, and it won't stop resend and until it, well, let me not say it won't stop resend. It resend for a number of period of time based on what is programmed in the application, like the FTP, to say resend 3 times or whatever, and then it's gonna say, listen, data connection or something. All right, UDP now. So we just look at TCP and how it works. This is UDP. All right, so here we go. It's gonna send a file same way across the internet, and it's gonna use in the TFTP, which is at UDP. It uses the UDP transfer protocol. So you know that is best effort. It's not going to be checking. It's not going to be checking. It's just going to send it and leave it there. I don't care. All right. So a file is sent to the server using FTP. All right. UDP segments the data to be sent and sends all data, and it's going to use the best effort. So look on it. File going with segments, and they send them all there. Bam, 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 bam. And that's it. The file server receive all 6 segments. No acknowledgement is sent. No, on the other side, this file server might only receive 3, right? But it's still not going to send any acknowledgement. All right, so UDP provides the basic functions for delivering data segments between appropriate application and a very little overhead. All right, it's not checking for anything at all. Okay. All right, so let us do our understanding now on UDP. I think I've run it over a couple of times, and so let us check our understanding now. For each characteristic, choose whether it is UDP or TCP. All right, so we have does not require acknowledgement. Which of the protocol is that?
UDP. UDP.
All right. Delivers data as it arrives.
TCP.
I didn't hear. Can I repeat?
UDP.
DP. Okay. Reliable.
TCP.
Fast.
UDP.
Resend lost data.
TCP.
Delivers data in sequenced order.
TCP.
Low overhead.
UDP.
does not resend lost data.
UDP.
UDP.
Acknowledges data.
TCP.
TCP.
Right, I know that everybody's correct, so let me check still. All right, good job. All right, just want to know that you are there. So we're going to move to application port numbers now. And I'm going to let you listen to this video before I say anything, all right?
TCP and UDP use source and destination port numbers to keep track of application conversations. Every network application is identified by the transport protocol using a well-known port number. The source port number is associated with the application that originated the request, known as the client computer. The destination port number is usually a well-known port number associated with the destination application on the remote device, the server computer. In this example, the user has entered the URL www.netacad into their web browser. The web browser is sending the information using the network application protocol, HTTP, which uses the transport protocol, TCP. The user's operating system has selected the TCP source port 1024 to refer to any communications coming from this specific web browser window or process. It is also using the well-known TCP destination port 80, so the www.netacad.com web server knows this data is for its HTTP application. After receiving the request from the client, when the www.netacad.com web server sends the client the data it has requested, it will be sent from its TCP source port 80. In other words, from its HTTP application. When sending the data to the client, the server will use the client's TCP source port as the TCP destination port. In this case, port 1024. This is so the client knows which specific application, the specific web browser window or tab, this data is intended for. If the client opens up a separate browser window, in this case, entering the URL www.cisco.com, a different TCP source port number will be associated with this specific web browser window. In this case, TCP source port 1555. Although the HTTP request message will be sent to a different server, the same well-known TCP destination port number of 80 is used to indicate this is for the HTTP application. When the www.cisco.com web server sends the specific client the data it has requested, it will be sent from its TCP source port 80, its HTTP application. The server will use the client's TCP source port as the TCP destination port, port 1555. When the client receives this information, it examines the destination port number to know which browser window the data is intended for.
Is everybody mesmerized, or we have a little understanding on that one? All right, so basically what is happening is that the port numbers, each application, there are application on the application layer, of the TCP model, TCP/IP model, each application on that layer, on the application layer, has a port number, and that's how you identify which application will be utilized. All right. So, for instance, a web browser, if you are sitting at your computer at your house now, and you want to browse to the internet, right? When you are browsing, you are using two port numbers, one a source port number and a destination port number. All right, so as the client, you are the one initiating the browsing. You are going to be using a source port number. Your destination port number is going to be the port number of the web server that you are getting to. So it could be www.google.com, right? You are going to get to google.com via port 80, the destination port. All right, so it will be the Google server and the port 80 that identifies that that is the port that I'm going to be using. All right, when that Google server is responding to you, it's going to respond to you with the port that you use in the beginning. So if you want to use 15, say for instance, your port number was 1555 as your source port number. When Google is responding to you, they are going to respond to you now, and the destination port will become your source, your port number, which is 1555. So communication and the knowledge of the application that is used on the application layer is so based on the port numbers that are assigned to each application. So you'll find that each application on the application layer has different port numbers. So they call them application port numbers. So for instance, I'll give you an example. FTP will use a port number 22. So whenever you see a file or whenever you see a particular communication with a port number of 22, you know that's a file transfer protocol. If you see a piece of data going somewhere with a destination port of 80, you know that is a web browsing or a web server that has to do with HTTP. All right, if you see that application going somewhere with a port number of 443, that has to do with HTTP, but the secured version. All right, and if you see application moving across the stream or the network with a port number of 25, then you know that port number is an email piece of application going to the email port, and so on and so forth and so forth. So each application, right, that operates at the application layer, they are identified by port numbers. Okay, class? And that's how it is. And each source, when a source is sending, it also has that port number for it to respond to. All right, and that's how it is. So on your computer, when you open up a web browser to browse to somewhere, you open up a web browser, immediately you're going to go through a port on your computer from your application, which is whatever the port is, and then you're going to try to go to port 80. You're going to try to browse through port 80 to the internet. All right, so keep that in mind. All right, so the classification of port numbers, huh? So TCP and UDP uses a source and a destination port number to keep track of application conversations, as I mentioned. So each application has a port number, that's how you know them. All right. The source port number is associated with the originating application on the local device, right? And the destination port number is associated with the destination application on the remote device. All right, so keep that in mind. All right. These are not physical ports. No, they are not physical ports where you look and you see a doorway and you see the number 80 there. No. All right. They are numbers that are used by the TCP and the UDP to identify the applications that should handle the data. So it's a way for each protocol to know which application they must deliver the data to, or which one of them going to take the data from them and handle it. All right. The source port number is dynamically assigned or generated, let me say, all right, to the sending device. And what is important is the destination port. Well, both are important, but the destination port number is those port number that are specific. All right. The source port number is dynamically generated by the sending device. This process allows multiple conversations to occur at the same time for the same application. So what I mean, you find that there could be many conversations going to the one port 80, but each of these originating conversations have different port numbers. All right, they will have different port numbers to identify these conversations. So for instance, Henley, Jermaine, Leon, Sean, everybody want to talk to me at the same time, right? I will have to recognize you via your voice. You understand? I'll have to recognize you via your voice, or I'll look and see when you're talking which name comes up on our screen. But multiple of you guys can speak to me at the same time, and it's only one destination you're sending that information to. And the way for me to identify who is talking to me, is that dynamically assigned sending port number. All right? So that's how it is. All right, this is all. All right, this is where I want. All right, the destination port number is 80 for regular web traffic, or 443 for secure web traffic. These are called well-known port numbers because they are consistently used by most web servers on the internet. All right, so those are two port numbers that you will know offhand: 443 and 80. All right, those two port numbers are important. So whenever you open up a web browser, and like right now, if you are logged into to we call it WebEx, you might see the protocol that you are using, the HTTPS, which is a significant, with the sign, it's way to tell you that you are using port 443. Once it is secured, it has a S at the end, then you're using port 443. Without the S, it will just be HTTP, and that will be port 80. All right. So those are two common port numbers, are well-known port numbers. All right. So source port numbers will different for each tab open. Meaning, if you open different tabs from your Microsoft Edge, your Windows Explorer, your Google Chrome, your your Firefox, or your Safari, to browse to one particular, each time you open up that tab, it generates dynamically a source port number. All right. And this is how your computer knows which browser tab to deliver the web content to. So whenever the web server responds to your computer will know which tab to deliver, or which browser to deliver the information to, based on that port number that the request was originated from. All right. Similarly, other network applications like email and file transfer have their own assigned port numbers. All right. So there are different number of different types of application layer protocols that are identified by TCP or UDP port numbers. All right. So we will go through them. All right. So if you look at the figure over here, you'll notice we have the World Wide Web protocols. All right. So we talk about the port numbers for www. You're talking about 53, and the protocols, you're talking about TCP and UDP, and the application protocol. So you have transport protocol, those two, and you have the application protocol, which is DNS, domain name service. So the domain name service protocols finds the IP address and associated with a registered internet domain for web, email, and other internet services. All right. It uses UDP for requests and information transfer between DNS servers, and it uses TCP for DNS response if needed. So it's not always using TCP, all right, but it will use the UDP when request and information transfer between DNS servers, between two DNS servers. Now you have port 80, all right, and the transport protocol for port 80 is TCP, and the application protocol is HTTP. All right. HTTP, as I mentioned, stands for Hypertext Transfer Protocol, and it provides a set of rules for exchanging text and graphics, images, sound, video, and other multimedia files across or on the World Wide Web. And then we have 443, that is the port number, and the transport protocol, all right, are TCP and UDP, all right, and the application protocol is HTTPS, Hypertext Transfer Protocol Secure, or securely, whatever. The browser uses encryption and authentication to connect with web server. So whenever you say HTTPS, you know you normally have a login, your information is encrypted, your information is secured. So class, if somebody asks you to log in and you know see no HTTPS, just don't bother logging. All right. Now that we know, you don't bother logging. If you didn't know and you do it, well, we understand. But now that you know, don't bother to log in. All right. And that's some. So let us look at some more. All right. So we have the email and the identity management protocols. All right. So some of these ports are 25, 110, 143, and 389. All right. The transport protocol for email, as I mentioned before, it is TCP, and because of reliability, that's a feature that is needed. All right. So SMTP stands for Simple Mail Transfer Protocol, and is used to send email from clients to an email server. It may also be used to relay email messages from source to destination email servers. All right. And these are the protocols that is when you're sending email. Another email protocol is POP3. All right. And you have different version of POP. All right. POP stands for Post Office Protocol. All right, you have different version. POP3 is one of the latest version. That's why it is 3. And 3 is used by email clients to receive messages from email server. You have the IMAP, Internet Message Access Protocol. All right, and it is used to receive email messages from a server. All right, it is more advanced than the POP3, and it offers a number of advantages, meaning you across the internet. Then you have, I didn't mention that port number. The port number for IMAP is 143. So once you see 143 anywhere set up when somebody's setting up an email, you know the protocol, the application protocol is going to be IMAP, and the transport protocol has to be TCP. For POP3, Post Office Protocol is 110. 110. You know them Corolla there? 110. All right. And so I'm trying to use images for you to remember. 110, you know, Corolla, that is for Post Office. All right. So whenever you see a port email has been set up and you see the port number put in as 110, you know it's a POP3. Or if you see POP3 put in, you know the port number is 110. Then you have 389, which is LDAP. All right, LDAP, that's how it's pronounced, and it stands for Lightweight Directory Access Protocol. And this is used to maintain user identity. We're talking about in an Active Directory or networking setup. All right. You know, like you have to log in, and when you log in, you know who you are logging, what you're supposed to access, and so forth on your network. So that's LDAP. All right. Application protocol. So user identity directory information that can be shared across the network and systems. It can be used to manage information about users and the network. All right, so that's what the LDAP is for, Lightweight Directory Access Protocol. We're looking at the file transfer and management protocols. All right, port 20. That is for FTP. All right, port 20 is for FTP. So when you see anything being transferred, if you're doing if you get advanced, or you're setting up a file transfer, it has to finish with the port number 20. It's reliable, so it's TCP. FTP stands for File Transfer Protocol. It's used to transfer files between computers. All right. It's considered insecure, but there's a version of it that is very secure, SSH. All right. All right. Oh, so, and that is on port 22. All right. Now you have port 21. That is TCP and it's FTP also. And port 21 establish a connection between the client and FTP server in order to start data transfer session. Then we have port 69, and the transport protocol for that is UDP, and the application protocol is TFTP, Trivial File Transfer Protocol. Uses less overhead than FTP, and it is less secure. All right, just remember 69 is TFTP. All right, 445 TCP is the transport protocol, and the applications are SMB/CIFS. All right, server message block or common internet file system. This allows for sharing of files, printers, and other resources between nodes on the network. All right. Then you have the Apple filing protocol. And that uses port 548. All right. And the transport protocol for that is UDP and TCP. The application name is AFP. And you have to ask if that only relates or proprietary to Apple or Mac OS. Remote access protocol. Sorry, class, if I hear me chewing. I'm going to give you a break in a couple of minutes. All right, let me just finish this slide. So the remote access protocol, we're talking about port 22 again, and that is what you call the SSH. All right, secure shell or secure socket shell. All right, and it provides strong authentication and encryption. All right, between client and a remote computer, especially like an example is like in a telnetting. All right, and then you have port 23, which is telnet. Telnet is an insecure remote access protocol. All right. So if you don't want to use Telnet because it's insecure, we're going to go SSH. All right. We don't know that it's secure. 3389. All right. Or you can just say 3389. That is remote desktop protocol. So for those who work on a network and they can do a remote desktop onto a next computer, that's the protocol that you use, remote desktop protocol. And the port number that is used for the destination is 389. Remote desktop protocol was used by Microsoft to provide remote access to a graphical desktop on a remote machine. It is useful for tech support situation. However, it should be used with caution because it provides a remote user with complete control over the destination computer. All right. Other network operation protocols are 6768, and that is DHCP, Dynamic Host Configuration Protocol, and that automatically provides IP address to the network host and provide a way to manage them. All right. Now we have port 137, 138, 139, and the application for that is NetBIOS. NetBT is the short. All right, and the transport protocol UDP, TCP. Guys, you need to go over all these protocols. I'm taking the time out because I know it's new to you to make sure I continue to repeat it. They have 161, 162, and that is SNMP, Simple Network Management Protocol. And that is when when you are managing a switch, like you're remoting into your home router. All right, that is the protocol. All right. And then we have 427 protocol. The transport protocols are UDP and TCP, and it is a service location protocol, short SLP, and allows for computers and other devices to locate services on a LAN without previous configuration. All right, where you can talk about like finding the print services and so forth. All right, one more, and these are the full table for everything. This is the full table. All right, class, I needed to go through it. All right, it's now 7:16. We're gonna take 14 minutes and we're gonna get back in class at 7:30. We're gonna get back in class at 7:30. All right. Take a break, take a wash on. It's a whole lot, and we're gonna come back and start or check our understanding. All right. Welcome back, everyone. Are we here? Hello, are we in? Okay, I can see. I can see.
Yeah. Yes, sir. Yes, sir.
Okay, so we're going to continue with check your understanding. All right, so for those who are still here, I hope everyone is in class. Let me see who of us, 10 of us in class. All right. All right, I've not seen Alicia and Anne-Marie. You're not there. All right, so we will continue. All right, so identify which application use TCP, UDP, or both by making selection in the appropriate column. So we have done something like this before, but now we are extending the amount of application. All right, so the port number is 20 and the application protocol is FTP. You need to tell me, is it TCP, UDP, or both?
The question, sir.
The question is, the application FTP, what does it use for transport? Is it TCP or UDP or both?
TCP.
TCP?
TCP.
All right, so for FTP control 21, is this TCP, UDP, or both?
TCP.
Okay, all right. And SSH, is this TCP, UDP, or both?
TCP.
It doesn't matter if I get it wrong, no, guys. We will see the answer at the end of it. We're just checking your understanding here. All right. Telnet, is it TCP, UDP, or both?
TCP.
All right. SMTP, is that TCP, UDP, or both? SMTP has to do with email.
TCP.
What about DNS? Is it TCP, UDP, or both?
Be both.
Both.
All right, let's check and see where you're at on this one here. Was everybody confident with the TCP coming down?
One by the day look away, but the vein coming at work. You ever notice when you exam you're going on one line too long, you just look away.
Yeah. Because I wanted to ask you, if you guys are sure. You understand? But yeah, Rowan was answering very confident. So I'll leave it alone.
So,
Okay,
you know,
yes.
before you go, because you see, all of these actually are reliable, so that's why I'm just go with the TCP most of the time.
That's right. Because FTP is file transfer protocol. All right, SSH is a secure shell or secure shell socket shell. What it does is you secure encryption connection across when you're connecting to across the internet or to a device. And Telnet is the same. You need response, so it has to be TCP. And there's no doubt that the mail transfer protocol need TCP. And DNS uses both protocols. So good job, good job, good job, good job. All right. All right, so we'll all right, so we're gonna continue now on wireless. All right. Gonna continue on wireless. All right. So while we're doing wireless, we're going to move to our PowerPoint slide. All right. And we'll come back to do our check our understanding. All right. Just give me a second. Share. PowerPoint. All right. So we're going to talk about wireless LAN protocols now. All right. So IEEE is a consortium of people, of brilliant minds, I would say, and not so brilliant minds, you know, and their responsibility is to standardize protocol, standardize technology, all right, so that there is a protocol for everything and it operates at a base, and so that whoever is going to come up with something new, they understand that it must fit into certain things and it must work in a particular way that users and manufacturers, integrators, and so forth understand and be able to put everything in practice. That's the IEEE, all right? The consortium of people. Now we have wireless protocols, all right? Wireless LAN protocols. So we have 802.11 protocol. All right, as a matter of fact, I'm going to say most of our network protocol, talking about Ethernet, you will get there in the chapter coming further down. All right, you will get there. But Ethernet is a protocol that deal with communication across the wire, the copper wire. All right, and then Ethernet is, the standard is 802, but it comes with something after that, whether 101101, whatever, right? So when wireless communication come into being, that protocol, that standard, that protocol that was built, it's also something within the similarity of the Ethernet. And so you have the same communication protocol, which is 802, and it's 802.11a. All right, so you have 802.11a, the wireless protocol, and the maximum speed of that when that comes into place and was certified by IEEE was 54 megabits per second. All right, and it has a maximum indoor range of 115 feet, and that will be 35 meters. And we're talking about without obstruction or obstacle, and it was traveling on a frequency of 5 gigahertz. All right, after that they said, hey, we need to get up, we need to get a different protocol, traveling at a different frequency. And so they have a lower frequency, which is a 802.11b. It was traveling, it was a smaller speed, but it was on a smaller frequency. And you might be wondering, why would somebody need a small, lower speed doing the same range at a lower frequency? Yes. So lower frequency means that you can travel through more obstruction, you know, like if there's a wall, or it doesn't matter what the obstacle is, it will get through it easier because the frequency is lower. That means the cycle is longer. So it takes a while. It is not easily degraded, or you understand? It's not, the signal is not easily degraded. And that's the 802.11 protocol. Then you have 802.11g, and it's still 54 megabits, and that is the maximum transfer speed. And it traveled at a the maximum indoor range was 125 feet, and it traveled at using the frequency 2.4 gigahertz, and it was backward compatible to B. All right, so that's improvement in technology. Then they improved the technology again to 802.11n, and that is now a massive improvement where it maximum speed is 600 megabits per second, and could go twice, almost twice as much, let me say twice, almost twice as much the maximum indoor distance as the previous protocols. All right, and so it can travel at a frequency at 2.4 gigahertz and at a frequency of 5 gigahertz, and it was backward compatible to all the previous standards, which was the 802.11a, b, and g. Now, what we have now is what we call Wi-Fi 3 or Wi-Fi 6, something like that, I remember. But it's 802.11.ac. All right. So you might be saying why AC, but if you look on it, all right, it's 1.3 gigabits per second. All right, which is 1300 megabytes per second. All right, and this maximum indoor range is 115, which is 35 millimeter. But guess what? Who cares? We're getting bandwidth. We don't need to go too far from it. We need to stay close. And it travels at 5 gigahertz, and it's only backward compatible to A and N. And the reason for A and N is because it's 5 gigahertz. And those are the only two previous protocols that uses the 5 gigahertz frequency. All right, so that's where we're at in wireless technology. And we have the Bluetooth. All right, Bluetooth, you can connect up to 7 devices for those who didn't know, to create a PAN, a personal area network. And the Bluetooth protocol is 802, or the Bluetooth standard is 802.15.1. All right, and the frequency is 2.4 to 2.485, or you could say 2.5 gigahertz. That's the radio frequency range. All right, then we have the RFID. That is passive or active tags used to identify the items. The passive is relying on RFID reader to activate and read. And the active have a battery to broadcast the ID up to 100 meters. All right, for those who see some of those tags that are in some stores or some other places, are those persons who have, what do you call it? Something gate. How do you call it?
Remote gate.
Remote gate, right. And those persons who have those entry cards that they use to enter into the workplace and so forth. Then you have the near field communication, which we mentioned in earlier chapter, and these devices must be in close proximity to exchange data. All right, and an example would be like your credit card. All right, so it is used for payments, printing, public parking, etc. For those who have gone overseas, because I don't remember seeing any here, but I've seen it overseas, where when you're doing public parking and you want to pay, then you just take a credit card and you don't put it in insert, or neither do you swipe it. You just pass it close by and it captures the information. All right. So we have two technology that is popular, very popular, but most of us probably don't know of it. All right. And those technologies are, you talk about Zigbee and Z-Wave. All right, so we're going to talk about them now. All right, and I'm going to put it to you guys from now. This is the research I wanted to do. I wanted to research on Zigbee and Z-Wave technology. Zigbee and Z-Wave technology. All right, and also I wanted to give me example of either technology being used in Jamaica right now, commercially and residentially. All right, I hope you remember that. All right, so Zigbee, it requires a Zigbee coordinator to manage client devices connected in a wireless mesh network. All right, and for those who can talk about like a wireless mesh network, you're talking like, for instance, a smart home. That's an example. When you talk about a smart home, then you're going to have a coordinator. A coordinator is not a person, basically. It is an equipment that does the management of all the connection, all the devices that are connected. All right. Device commonly managed from a cell phone app. So your cell phone can also be your coordinator. All right. Good. So that's where it works for your smart home or any other smart home devices like your Google Smart Home and so forth and so forth. All right. Then you have the standard for the Zigbee is 802.15.4 standard. All right. Just remember the standards. 868 megahertz to 2.4 gigahertz frequency. And this signal can travel up to 20 meters, and it can take up to 65,000 devices and data speeds up to 250 kilobits. So you know, it's not traveling at high, it's not traveling on large bandwidth. No, it's not. You know, it's for connectivity purpose mainly, and for simple data transfer, light, very light data transfer, or you would say very light instructions coming from the coordinator to do a task or to do what it needs to do. You know, like to turn on the light or to turn off the light, turn on the lawn, and so forth and so forth. All right. Then you have Z-Wave. Z-Wave, that is a proprietary standard. All right. But a public version is available, and 232 devices can connect to a wireless mesh network via data speed of 100 kbs. All right, so the Z-Wave has less devices connecting to it at a slower speed, and it is proprietary, meaning it is belonging to a particular uh, um, manufacturer, and that manufacturer only want their own devices or equipment to work on that network, even though it says there's a public version available. All right. Cellular generations. All right. So this is the movement of cellular over the years. For those who know, those who don't know, you're going to learn something. All right. So 1G/2G, and that is the first generation, was analog calls only. For those person talking about the fridge phone and those phones from long time ago. I don't know if anybody in class know them. All right. Then 2G was introduced. Digital voice, conference calls, and caller ID with speeds of less than 9.6 kbs. Man, you know, that is small, like basically no speed. All right. Then we talk about 2.5G, and this support web browsing, and we're talking about web browsing, talking about very light HTML applications, very light, short audio and video clips with speeds of up to 237 kbs. So we're talking about back in the time when you have the Motorola Razr and them Motorola wait, next one name Flip or whatever. Those phones and the Sony Ericssons, those phones that were in existence and very popular at that time. And used to have also like the Nokia, right? So hello? Hello?
We're here, man.
Okay. So these are some of the technology that has traversed time with us. I mean, we traversed time with them, but we left them somewhere. They're not here. Then I remember the time when 3G was a big thing coming in. full motion video and streaming of music of up to 2 megabits per second. Can you believe that? That's where we're coming from. All right. Then after 3G, everybody talk about 4G. And 4G, we know a lot of us experiencing 4G now. All right. IPv6, IP-based voice. When we talk about IP-based voice, we're talking about voice over IP. We're talking about making calls using WhatsApp, Facebook Messenger, and those voice over IP application that is in the event of 4G. We're talking about gaming services, playing some top quality games or high bandwidth games on our phone, high quality multimedia, the YouTube and those stuff at speed of up to 672 megabits. So we have grown to 4G. And then we're coming to the era of LTE, long-term evolution, for those who don't know what it means. And it means the 4G speed standards and improve connectivity while in motion, meaning while you're driving, you are connecting almost seamlessly. You don't even know that you miss a beat. You understand? Speed of up to 100 megabits when mobile and up to 1 gigabit when stationary. So if you stand up one place near your house where you have LTE, you're getting speed. And if you're driving across the country, connecting to to and from LTE towers, it will be seamless at a speed of about 100 megabits per second. Is almost like you're not missing anything. All right. Then come the era of 5G, which is 2018 to now. All right. And 5G was rolled out mostly in 2019 and is still rolling out because it has not rolled out everywhere in the world. All right. It's not even fully out in the US and most first world countries. 5G support augmented reality, virtual reality, smart homes, smart cars, data transfer between devices. And when we're talking about high-speed data between phones and so forth, you connect to your fridge, your TV, or whatever. You understand? You're talking about connection to drones and those things. 5G is what going to propel or move the population, or the future of technology is 5G, moving it forward. All right, you can get download speeds of up to 3 gigabits per second and upload speed of 1.5 gigabits per second. So when you're talking about autonomous vehicle, like the Google autonomous self-driven vehicles and so forth, you're talking about 5G. All right, so basically 5G is here and here to stay, and it's going to move technology a leap and bounds ahead of what we know it to be. All right, as it relates to the, like for the cell phone, the mobile phones, we don't have we don't have much 5G signal, we don't have much 5G signal in Jamaica as yet, even though we are buying 5G phones. So whenever we are start getting 5G signal, then we should be good, I hope.
That means I say, oh, buy 5G phone. That means in a move or it's supposed to move then.
Yeah, 5G phone, the technology, we're not using the 5G technology. Client server roles. All right, so client server roles. We're talking about client server, we're talking about a computer connecting to connecting in a network and feeds it information from a server. And we're talking about, like, you can have a thin client or you can have a thick client. Remember, we mentioned those two in earlier chapters. Thin client rely on most of the resources and everything from the server, and a thick client will carry their own hard drive and memory and so forth. So file and client server, web client and server, email client and server. So we think of it that kind of way. All right. So a web client connects to a web server, an email client connects to an email server, and a file client connects to a file server. All right. DHCP server. All right. DHCP server. And it's a server that provides IP addressing information. All right. So what it does, all right. So yeah, the IP address on a computer is that unique number that identifies the computer or the device or the host, we call it host, on a network. All right, it could be we call them either computer, a device, a network device. We call it an end device or a host. All right, so IP address is that unique number that identifies that on a network. All right. A DHCP server provides the IP addressing information. So how the DHCP server work is that it automatically give IP address to these devices. Now, without a DHCP server, you'll have to manually give these IP addresses to the end devices. And you will say, oh, that is not an issue. Yes, it's not an issue. If you have 10 computers in your organization or 20, it's not an issue because you can go around and give each one of them an IP address, right? But what if you have 200 computers in your organization? You're going to take a very long time to go around and put in IP address and then to record them so that you know which one of them have this IP address and XYZ. Because guess what? You don't want to mix them up. Because if you mix them up, then you're going to have a conflict because the two of them going to have the same IP address and then it won't work. It's going to be a conflict on the network. All right. So the DHCP server make lives easy for the system or the IT manager, wherein the server is configured to automatically provide IP address to each device. Any questions, class? Any questions? Any questions?
Not right.
All right. A DNS server translates domain names such as cisco.com to an IP address. And if you remember, I'll give you kind of allude to it earlier. So the IP address is a unique number, right? Even on the internet, every computer on the internet has an IP address. You have to remember the internet stands for international networks. All right, so it's many web servers all over the world that combines to be the internet. All right, so a DNS server translates domain names. All right, so a domain name is like www.cisco.com, or you can just say cisco.com. That is a domain name, right? And each domain name must be given an IP address. Every domain must have an IP address. Keep that in mind, class. Every domain must have an IP address. Some domain may have multiple IP addresses, all right? But the important thing, it must have an IP address. All right. And what happened is that you cannot afford to remember all the IP addresses. Take, for instance, Google, as I mentioned. Google has hundreds of IP addresses, maybe thousands of IP addresses, because Google have thousands of servers all around the world. So when you type www.google.com, it's not going to any one particular server put in one little room in the United States. No, it's going to resolve based on where you're at in your region to that server. All right. So when you type in google.com, you don't even know which IP address it resolves to, unless you know how to do a resolve, a domain name resolve, to find out which IP address is this domain particular that you're connected to using. All right. Anyway, but they are just to explain to you that it is a number that is assigned to the domain, but because we won't be able to record all of these numbers in our head, I would have ever lost in the big book for record them as we know them. So that's like a telephone number. You know, like telephone number, you have to go and look in a telephone directory one time gone, long time ago. Long time ago gone. You know, whenever you want to make a call to somebody, that everybody in Jamaica who has a landline back in the days, their number was placed into the telephone directory. And if you want to make a call to somebody, you have to take up the telephone directory, that yellow book, and search through alphabetical order to find the person's telephone number to dial them. Or if it's a company, you do the same. Telephone books does exist today, but hardly utilized because everybody has Google. You understand? everybody can just say and look for the telephone number, or they go to the yellowpages.com or something, right? So that is what it is like when I talk about a domain name and an IP address. Every domain name has at least one IP address. We can't know them out of our head because we're not trying to study them. So we just want to hear the name. We type it in our search bar or in our URL field, and the DNS server will translate that name to the IP address, or it will translate that IP address to the name. So if you type in 198.133.219.25, right? www.198.133.219, it's gonna bring up cisco.com. You understand? Because that is the IP address. And if you type in cisco.com, it's gonna look for that number and bring up the server just the same. All right. So that's how the DNS server work. Any question on the DNS server, class? So the DNS server responsibility is to resolve number to letter, or to alphabet, to alpha, and alpha to numbers. All right. So it's not one way, it's two way, because the server has to resolve everything. All right. So the client don't have to need to remember all the numbers. Print server. A print server now. What a print server is on a network, as I'm talking about networking. What it does, it controls multiple printers, and it provides the client access to print resources. It allows centralized print job administration and provides feedback to the network clients to say if you can print or you can't print. All right. So what it does is a management with a software or hardware, because it can be one of the two. And what it does, it manages the resources of the printer, the network resources, to printers that are connected on your network. So when you print to that print server, it directs to whichever printer you are sending the job to. All right? And it will give you feedback and so forth. We will go into print server a little more down the road. File server. A file server allows client to access files using specific protocol. All right. So to access your files, you're using your FTP, all right, or FTPS. You can be using a SFTP, or you can use SCP, SCP, like I say, Win SCP, Win Skype, for those who are a little computer savvy there. All right. And what you use to do is to transfer files, to access files, across the network. Remember, we are talking about network now. We're not talking about on your hard drive. We're talking about on the network, meaning you are trying to access file somewhere remote of where your computer is. And it doesn't have to be a remote location from where you are. You understand? It could be in your own organization. All right. Then we have a web server. A web server provides web resources using the protocols HTTP or HTTPS. All right, secure. You have the SSL or the TSL. So these, the HTTPS and HTTP are web browsers web browsing ports, and then you have the SSL, TLS, and those are more like emails. It still works pretty good on it's still a part of the browsing, the internet service. And you have TCP port 443, which is also HTTPS. All right. Class, any questions? Because I know I might be moving a bit fast just now. Any question? All right, don't be. All right, just want to make sure you understand. We're going to do our check our understanding soon. We're just going through, and then we're going to do our check our understanding at about 20 minutes after. We'll go through a check our understanding. All right. So mail server, email messages are stored in database on mail servers. All right. So we go through that a little bit more in chapters coming down. But just to let you understand, whenever they're talking about mail server, whenever email is sent, most of you wouldn't even remember back in the days when you have an email address, your email address would be like say Michael Dawkins, it would be mdawkins@cwjamaica.com. So I have an email account at cwjamaica.com, and they gave me a login. And when email is sent to me, it is stored on their mail server. Now, if I don't want it to be stored on their mail server, even though it must come through their mail server, and we'd have to use the post office protocol, POP3, or the POP protocol, the original first one. And then that email will be then downloaded onto my device. Understand? But however, that email has to come through their mail server. It's the same thing in a sense now, because for most of us who have Google emails, or let me say Gmail, and those who have Yahoo, those who have, you know the rest. Hotmail, Live, whatever, you know the rest of email that exists out there, right? For those who have those emails, then the emails is stored on a server, all right? And you just only log onto the server and read your email, delete it if you want it, delete it, or keep it there, all right? So that's that's what I call a mail server. So if you look on the diagram on the screen here, you will see a sender, you will see a recipient. All right, so the recipient is going to send an email to, the sender is going to send an email to this recipient over here at cisco.com. When they send that email, it's going to traverse this router right here, because the router is what going to take it outside the network and bring it into the internet, onto the internet, and then it's going to find them using the mail protocol. It's going to find the mail server. There it is. Go here. All right. And then it's going to come to BAM, the ISP, Internet Service Provider A, and they have their own mail server. So you could have called them cwjamaica.com. And then it's going to move from here using the protocol across that speaks to mail server. The mail server to mail server use the protocol SMTP, and that is the protocol that's used here now. And it comes to the mail server of the recipient, which is this one here, ISPB, comes down through their router. They're going to use the IMAP or the POP3 protocol and come all the way into the recipient. And that's how it is traversed. Proxy servers. Proxy servers, you know, when somebody talk about a proxy, that's somebody that's working or on behalf of you or representing you. All right, give me a moment, please. Sorry about that, class. So proxy, anybody talk about a proxy is somebody that is representing you. So for example, if you are going into a meeting or you are scheduled for a meeting and you can't go to the meeting, you can ask somebody to represent you at the meeting or to be your proxy at the meeting. What that person is going to do, go to the meeting representing you, take all the information, and anything that person speak on your behalf based on the permission that you allowed, it will be accepted because that person is a proxy. So a proxy server acts on behalf of a client, all right, thus hiding the real internal host. So when you're talking about computers now, that's what it is. All right, so for you to come into or get out, you're going to use a proxy server To browse to the web, you're going to go through a proxy server. So you're basically not going directly onto the internet. All right. So whatever the internet see is not the computer, but it will see the proxy server. All right. So a representation here. So this is the client. This is the router right here. And it acts as a proxy server, which stands between the client computer and the internet. All right. So when you browse, you are browsing through the proxy server. When the internet is speaking back to the client, it's speaking through the proxy server to the client. So the proxy server is the middle person, the representation for the person or for the computer. All right. Used to cache frequently accessed web page. So that is one feature of a proxy server, by the way. So for a website that you go to very often, it will cache it, and cache mean that it store it, have it put aside so that when you need to go to that website again, it just easily just find it, you know. You don't have to bother try send out to resolve or anything like that. It's already there. It's a proxy server.
So like when it's just like when you start type the name in the address bar or the Google search, you see the website come up for you. The name come up so you can just click on it and then go to the website. That's what I mean.
Well, that is not a proxy. That is, we call it a predictive text. That is predictive. All right. So cache is a storage. When you talk about cache, you're talking about a temporary storage. You understand? So I'll give you an example. When even on your computer now, your computer that you use, when you're browsing and you're browsing history, that's a cache. All right, your browsing history. So whenever you go into your browsing history, like you open up Google or some other website, no matter. All right. When you open up some other website, it will automatically direct you to where you were the last time or so forth. You understand? And or automatically just it will find that web page for you quick in no time because it's already cached onto your computer. It's stored there. If you are typing in something in the Google search bar and it automatically finish what you were typing, that is predictive text. It's a little bit different. Okay.
But me like sometimes when I type it like in the address bar before, like you say, if you go to like if we
in the URL field, right. Get what I'm saying? Yes. Right. Definitely. All right. So, but that is not proxy, no, that is a cache. The proxy store all of these URLs and frequently access web page so that when you want to go there, it don't take no time for you to get there. You don't use up a lot of resources. All right. So just remember now, that's how you set up a proxy. That's the use of a proxy server. Then you have authentication server, the AAA server, I call it. I call it the AAA server. Authentication, authorization, accounting. And this allows access to a network device or a particular network. So a very prime example of a authentication server, and they call it like the radius server for those who know, have some knowledge of technology. But you know, like when you are, say for instance, you go to you're using some internet setup. All right. You're using some internet setup. I'm trying to find the most easy one. You go to some bank. Right? I don't want to use that. Trust me, I don't want to use that one. Like you go to some hotel then, right? And you go to the hotel, and what happened is that when you log in, they give you a username and password, and Sandals is a good example. They give you a username and a password to log into the internet, and that username and password ties to your check-in. That means that when you check out, that username and password is not valid, right? So you find that you get to authenticate to their network, which is the Wi-Fi. You are authorized to use their network because they get authentication, and the accounting process is that they know you. So whenever you check out, you are not there. And so the AAA system works from many different ways, even in an organization where you work. That's how it works. But I wanted also to give you something that you probably will see in operation and see how it works. So like some hotels, they use that where they authenticate you based on that you're a guest, and then you're authorized to use the network, because authorization comes after authentication. Because authentication is a login, then you get authorization to use the network. And accounting is to know who you are, all right? And to make sure that when your time comes for left, you're left, as in you're disconnected from the network. So the client establishes a connection with the router. The AAA router prompts the user for a username and password, which is it, and the router authenticate the username and password using a remote AAA server, and the user is provided access to the network on information in the remote AAA server. So that is the authorization, all right, and accounting is just knowing who you are and what you can do. All right, syslog server. Syslog server now stores network messages sent by networking devices. All right, and it's basically data down. There's no big explanation for that. All right, so what it does is it sits on your network, and sometimes the syslog server is also on the device, right? And what it does, it's any network messages sent by network devices, it stores it, and you can decide what messages are stored. So you can say you want it to store you want to store when somebody was logged in and access was granted, or you want to store when somebody or you want to you're requesting sharing my screen. All right. So 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 you understand what I'm saying. Sorry about that, guys. I was a bit distracted just now. All right. So basically what I'm saying is what I'm saying is what I'm saying is that some of these messages, you can tell what messages are stored from what messages are not stored. Okay? And that's what a syslog server is for logging messages on your system from network devices. Okay, so we are on 5.3, basic network devices, routers and switches. All right, this is the final part of chapter 5. But before we get to 5.3, we're going to check our understanding, because time is running out, and want to make sure we go through check your understanding for this portion or this section of chapter 5. Any questions, class? Any question at all?
Not right now.
Oh, I'm muted. Okay, okay, okay. Wow. Class, can you see my screen?
Yes.
Okay. All right. So what we're gonna do, is just give me a second. Find my screen right. All right, so what we're gonna do is we're gonna drag the wireless protocol to match the characteristics. All right. All right, so let's go. I will read and you tell me what to put there. A legacy wireless LAN standard with a maximum speed of 54 megabits. Which one is that? Is it 802.11g or is it 802.11ac? I'll give you, I'll narrate down for you guys to even get the answer.
802.11g.
All right. 54, is it 54 megabits? All right, sorry guys. All right. The standard that all wireless LAN should use when implementing new devices. The standard that all wireless LAN should use when implemented new devices. New devices. Implementing new devices.
802.11ac.
All right. Are all the ladies I'm not hearing any ladies, Karine? You know, I want to hear your answer. 10 ladies here. All right. You want to take up for the rest of the ladies that are not here. All right, so let's go. Third one, a wireless PAN, personal area network technology that supports up to 7 connected devices.
Bluetooth.
Bluetooth.
Okay, because I know that I stress these things. A tag and reader system that can accommodate ranges from 25 meters for passive tags and up to 100 meters for active tags. And I remember I was giving an example.
RFID.
Okay. A secure close proximity transaction system typically used for wireless payments.
NFC.
See.
Right. A proprietary smart home standard that can support up to 232 connected devices in the same wireless mesh network.
Z-Wave. Zigbee.
You say it with a lot of doubt.
That's a mic and Zigbee to me still.
All right, so let us see. A smart home standard with some open source code that uses 802.15.4. Which one is that? A smart home standard.
Zigbee.
Remember, talk about the smart home standard that uses the coordinator. And the coordinator can be your cell phone, where you say turn on the light, turn off the light, turn on the radio, turn on the TV, turn on the
Zigbee.
sprinkler,
So
alarm
basic.
clock.
Zigbee.
Okay. A technology that meets the standards for 4th generation mobile phones.
LTE.
LTE.
All right, so I guess this one is the last one, eh? All right, everybody agree with everything that is on screen?
Yes, sir.
All right, so let's check our understanding, eh? There we go. Good job. Just remember that Z-Wave is relating to proprietary. So because both of them begin with Z, just remember wave is proprietary. All right? And you don't have to worry about the next one. The one, or you can say B, deal with the coordinator. All right? All right, so we have done this. And we're going to find the next, check your understanding. Where am I? Let's find the next, check your understanding. Just give me a second. I'm just scrolling to it. All right, here we go. All right, so this is the last check your understanding for the day. And we'll finish chapter 5 on first hour, in the first hour of Thursday's class, and we go to chapter 6. All right? So instruction, drag the server that matches the description. All right, I will read and you tell me what to put where. All right, first up, it provides IP addresses to host on a network.
DHCP.
Bottom to Tenley. Tenley not there? Karine? Come on, ladies. I'm listening out for you. All right, translate a domain name such as cisco.com to an IP address.
DNS.
Okay. Uses protocols such as FTPS, SFTP, and SCP. Those are what they call file transfer protocols. So and it uses these protocols. Which one is it?
Yeah.
Try again, man, because I can't put in that one because that one totally wrong. Try again, man. I don't want any wrong one come up. Think of it. Uses protocols such as FTP. That's why I almost give it an answer, you know. FTP stands for file transfer protocol, right? So it has to do with the file server, all right? Uses protocols such as HTTP and HTTPS to display information in a browser. Which server is that?
Web.
Uses protocols such as SMTP and POP3 to send and receive messages. Which server is that?
Yeah.
Provides the ability to cache web pages for quick access. Which server is that? Typically uses a AAA server.
Syslog.
No, authentication.
Okay. Remember, AAA stands for authentication, authorization, and accounting. All right?
Yes, sir.
And the next one says provides a method for storing system messages from networking devices. And that's a syslog. All right? Here we go. All right, so when we get back to class, this is 5 point, I think it's 5.4, I think, or 5.3. This is the 5.3 section. So when we get to class on Thursday, we'll definitely finish in chapter 5 in the first hour, and we'll go straight into chapter 6 and maybe complete it. We will only, I'm telling you, because I want you guys to go through chapter 5. All right, with a fine teeth comb. You will be doing chapter 5 and the checkpoint exam over the weekend. All right, and remember, you are going to research on ZigBee and ZigWave. give me a research on it, and tell me of the usage and if there are any usage of those technology in Jamaica residentially and commercially, and give example. All right. Simple. So that is your research for the weekend. It's not for the next class, it's for the weekend. So I'm just telling you from now. All right. And because of the lockdown, I'm gonna give you the exam until the lockdown is over on a Monday evening up until midnight. All right. So there we go. Any questions, class? When we done chapter 5 on Thursday, God's willing, we will do the quiz together so that you guys are prepared for the exam. I want you to read ahead. I want you to review. Review and read ahead. I will send you the PowerPoint slide for chapter 5. But as you realize that I've gone to the NetAcad site a couple of times for the video and a check understanding, I would want you to review using NetAcad also. All right. So you have tomorrow to do that, and Thursday we are going to finish it off and go into chapter 6. All right, everyone. Any questions before we leave? This is the time that I can take questions. Any questions?
None from me.
Yes, sir.
No concerns? No
the labs,
questions?
yes, sir, the labs already, if it's in there, we can send it to your email.
Yes, for those who are not enrolled in Moodle as yet, send it to my email. I love when it is done in Moodle because I can score and put a grade right there. All right.
Oh, in our mode is known as one place I must name private files. I think there's some
No,
upload.
it would have to be on the. But Kevin, I think I see your name in Moodle. I think you are in Moodle. So you will. It's not on a private files. You would go to the assignment and do the upload.
Go to the assignment and do the upload.
Right. I'm gonna try and put in some videos. I'm gonna send you some videos. As a matter of fact, I would prefer you to look at the videos that comes with the NetAcad site for this chapter. All right, these videos that come with this chapter are extensive, and I think you guys should go through this NetAcad version and look at the videos.
I'm gonna say assignment.
On the what chapter are we doing? Chapter 3? Chapter 3, right? The labs. All right, let me look on it and see if the assignments area is activated. If not, I'll do it tonight.
Because sometimes I activate and you have last year dates.
Yeah, notice. All right, so let me activate chapter 5 and chapter 3 assignment if it is not.
All right.
All right, any more questions?
It's supposed to say chapter 4 assignment.
Chapter 3 you're at. Chapter 3 assignment.
Okay, I'm gonna see it for chapter 3.
Yeah.
Oh yeah. When you go in a chapter 3 assignment, we get like some orange tab. It's a last modified time remaining grading status. But I click add submission.
Right.
Okay. I can upload it from here. So.
Hawkins.
Yes, sir.
I think a message I sent to you the other day. I not get back a response. But you can't respond with a message. I have to really say anything else still, but you can't respond in the message.
Okay, you send it to it. You send it to me or to the group?
No, man, to you personally.
Okay. If you can send your assignment as an email, that is the one.
No, sir, no. Take a message from Rowan.
From Rowan? Okay, hold on. Okay, hold on, Rowan. Hold on. Let me look and see. Okay. Okay. No problem. That is not an issue. That is not an issue at all. Everybody has 2 tries.
All right, no problem.
All right, cool. I can mention it. I can mention it to everybody. All right, class. Everybody has 2 tries for the exam. If you miss it, you can try again. All right, you have 2 tries for the exam. Just let me know and I get it reactivated. But I want you guys to complete the exam when I give it to you. All right.
No, you get the option to upload one file. When I upload one, then when I get back the tab where say add submission, man, we can edit submission.
Let me look on it. Let me look on it. All right, because I probably need to update him. What I do, I normally update for the assignment as I go along. All right.
Because morning notice it to you say you can only send like one file. You can add more than one.
Yeah, that may I realize.
Right.
Okay, say.
Dawkins.
Yep.
But when you send the assignment, how do I say edit submission? But you get a message say the assignment is submitted, right?
Right.
Okay. So that means you would eventually see say it's submitted.
Yeah, you go see it said upload.
No man, I see it.
Okay. But you can add more than one file to it then.
Yes, definitely. No, you can add more
it.
than one, but what I need to do is to give it a permission.
Okay, add one still, so never another one on that one add, but I get that option right now.
All right, let me go in and check it.
I mean, if you get the option, definitely just send it to your email.
Yeah, for some persons are not enrolled, that I realize, in Moodle. If that is the case, then, because I was speaking with this institution, then if that is the case, I would just send me the email so I look at what you do, because I need to see that you know what the question is, you have an understanding what to answer and so forth. That is important for the assignment. You understand? So I can gauge your level of understanding. And it's also good for you too, because you get information that will stick with you.
Yeah.
All right, I'm going to look at I'm going to log on to Moodle. Just give me a second.
Have a time limit to this because you have your time out most of the time, you know. So you have a time limit to it.
You know, I don't know, to be honest, for Moodle. For Moodle?
Yes, or the NetAcad, both of them.
In NetAcad, yeah, the NetAcad, if it goes, I think it's 30 minutes. If it goes idle for 30 minutes, it logs you out. But that is long, so, you know. All right, let me look on chapter 3. Chapter 4. Okay, you don't have an assignment folder on chapter 3. You have the lab. Okay, let me, lab assignment. Okay, let's see what's going on here. Okay. To show that. Lab assignments.
that means assignment 2 no go through them.
Where did they save it?
Ne?
Save it assignment. Assignment 2. When we did assignment 2, you give me one last year date, but only the assignment one they have the accurate
No,
date.
no worry about the date. As long as they upload it, it will be there.
Oh.
Mm-hmm. All right, so maximum number of files to upload is 2. I'm gonna put it to 4.
Yes, I can.
Okay, so all right, so let me tell you who and who. Let's view all submissions. All right, so I have Ladine, Tenley, Rohan, Karine, Shevakar. I don't know who's. Oh, that's Tevin.
Yeah.
Tevin, but you can upload Tevin and Tyrese.
Yeah, but I'm only getting the option to upload one file.
One file.
Yeah, I uploaded one.
Okay, well I just changed it now, but other person's uploading 2, so I don't understand why you're getting 1.
All right, so when we go to
It was 2 originally.
We'll go to chapter 3 assignment.
Chapter 3,
All right,
you can upload 4.
Let me see which part one already upload. Underneath that, when we click to upload that one, it only has an edit submission. We cannot add anything else. So we only can edit the one we already upload, like delete it or change the folder name.
The thing is that I can't see what you're seeing, that's my problem.
Okay, and in the top right column, say maximum number of file 1.
4 I have. 4 I said for it.
Probably we need for log out and log back in.
Yeah, probably.
So what Tevin can do is before him send out, him kind of drag the file in the box, the part where it say drag the file.
Right, yes, you can drag, right.
You drag the file into that box before you send it off.
Right.
Okay, but I not get the option there again either. The only option I can get is edit submission. When I click on edit submission, I see the previous file when I just upload. And then I see save changes or cancel.
No, because you send it off already, that's why you're not gonna get that option there again.
You're uploading other assignments, you said, right? All right, let me save that. Try uploading it again now.
Upload the other one?
Mm-hmm.
All right, let me try again. Still I get the same thing, edit submission. Okay, we can add one next one now.
Mm-hmm.
All right, so. All right, so I'm gonna upload both of them.
Okay. All right, so I'll look at all the assignments tomorrow. Those by email and those that are uploaded.
All right, so we can log out now. See that we upload the file, right?
Yep. All right, everyone. Good night. Have a good night.
Good night. Good night.
All right, everybody.
All right.